In this tutorial I will use Raspberry Pi Pico and then show how you can log data from a sensor and save it on a text file using a MicroPython. So basically we will cover the following. So we will log temperature data from a sensor using MicroPython, and we will use a basic TMP36 temperature sensor, and then we will log the temperature data on a file on the Raspberry Pi Pico device. Then when the logging is finished, we will copy the file to our PC, and then we are ready to do some data analysis. We will create a simple Python script that opens the file and plot the data, and here we will use ordinary Python and matplotlib. So what do you need? You need of course a Raspberry Pi Pico. You need a micro USB cable in order to connect the Raspberry Pi Pico to your computer. Then in this tutorial I will use the Tony Python editor, but of course you can use another Python editor if you prefer, but Tony editor has built-in features and support for the Raspberry Pi Pico. You need of course a sensor. I will use a TMP36 temperature sensor, but of course you can use another sensor as well. And then I will use a breadboard and some wires in order to connect it to the Raspberry Pi Pico. So then let's start with a short overview of this TMP36 temperature sensor. So here you see an image of the TMP36 temperature sensor. It has three legs. One is voltage in Raspberry Pi Pico. We use 3.3 voltage reference pin, and then we have a ground pin, and then we have the analog voltage output here that we connect to one of the analog to digital converters on the Raspberry Pi Pico, and then we will convert this signal to a temperature value in degrees Celsius. Here you see how we wire the TMP36 together with the Raspberry Pi Pico. So then the voltage pin here, the power supply, connects to 3.3 voltage on the Raspberry Pi Pico, and then we have the ground pin that you connect to one of the ground pin. You can use of course any of the ground pin on the Raspberry Pi Pico, and then in the leg or pin here in the middle are connected to one of the analog input pins. You can use either ADC 0, 1 or 2. In this example I use ADC 0. So in order to convert the voltage output of this TMP36 temperature sensor, you need to scale it in order to convert it to temperature in degrees Celsius. And then from the data sheet of this temperature sensor you will find this plot or chart, and based on that plot we can find the relationship between the output voltage and the temperature in degrees Celsius. And then we end up with this basic equation. Y is the temperature in degrees Celsius and X is the voltage value. So then Y equals to 100 multiplied with X minus 50. So then we need to use this formula in our MicroPython application in order to convert it from voltage to temperature in degrees Celsius. So basically then we end up with the following basic MicroPython application in order to read and calculate or find temperature values from this TMP36 temperature sensor. So we need to import the machine Python library in order to use this ADC on the Raspberry Pi Pico. And then basically we have just a simple while loop, and here we read the raw ADC value using this read U16 function that is part of the machine library. Then we need to convert it to a voltage value using this basic formula. And then finally we need to convert it to degrees Celsius using this formula. And then in this basic example I just print it, and then you see the values appearing here in the shell in the bottom of the Tony editor. So we'll use this as a starting point for creating the data logging application, where we basically will save this temperature value to a file on the Raspberry Pi Pico. So now we know how to read values from the temperature sensors and put it into the getting the values inside the MicroPython application. So now let's see how we can start logging data or values from this sensor and save it on a text file and use that for later data analysis in using an ordinary Python application. So basically, we will read data from a temperature sensor using the Raspberry Pi Pico and MicroPython, and then we will log temperature data on a file on the Raspberry Pi Pico device itself, and then we will basically just copy the file to our computer, and then we are ready to do some data analysis, and then we will just create a simple Python script that opens that file and plot the data, and here we will use ordinary Python and the matplotlib. So here you see a system sketch of the entire data logging and analysis system. So we are already able to read data from the temperature sensor. Then we will save data or the actual temperature value to a file that are stored on the Raspberry Pi Pico device itself. And then after some time, when we are finished logging, we just copy this data file to our computer for data analysis. And then we can create a new application or a Python script that are able to read the data from the file and plot it. We can do some we can calculate some statistics. We can create data models, etc. But in this basic tutorial, we will just create a basic chart using matplotlib. Before we go further, we need to know the basics regarding file handling in Python. We need to know how we can save data to a text file and then open a text file and to be able to read data from that text file. So basically, here you see the basic file handling operations in Python. These works in ordinary Python, but those operations also work in MicroPython. So in order to write data to a file, we just first we need to open it using open, and then specify the file name, and then use W for write. And then we can start writing data to that text file. Here I just write a text string, hello world, and then I can continue writing data to the file, or I can just close the file. And then basically these 3 lines make sure that hello world has been saved to this text file called data.txt. And then we can do the opposite. In order to read data from a text file, we can use open, specify the name of the file, and then use R for read, and then we just use read instead of write in order to put data from that file into this variable here called data. And then finally we can just close it. So basically these are the basic file operations in order to write data and read data from a text file. So basically here is a simple example that opens and write data to a file in Python. So then I just specify the file name using open, specify write, specify the data that I'm going to write to the file and using the write function, and then finally close it. So here you just see these basic examples in the tone editor, and then this is the application, and then here you see the file data.txt that has this text hello world that I specify here. But typically you want to save data inside a while loop, because if you are going to log data from a temperature sensor, you typically need to have a while loop where you read data from the sensor and write that data to the file in every iteration inside the while loop. So basically this is a basic example showing that. You specify the file name, you use open, and inside the while loop you specify the data that you are writing, and then you want to include a /n for a new line inside the text file. Then you use the write function, and then also you need to use the flush, because if you don't use the flush, the data will not be saved to the file in each iteration inside the while loop. And then When the while loop is finished, you just use file close as in the previous example. So basically here you see the results of this basic Python file, Python script. So inside the while loop you just write hello world to the file, and then use /n in order to create a new line, and then the ending result will be like this. So in each iteration inside the while loop it will write hello world, create a new line, and then in the next iteration it will create hello world, and then it goes until the while loop is finished like this. So now that we know how to read and get data from the temperature sensor, and then we know how to do basic file operations in Python, we are ready to start creating data logging application itself. So basically we will read data from the temperature sensor using Raspberry Pi Pico and MicroPython, and then we will log the values from the temperature sensor on a file on the Pico device itself. So now I have opened my Ton editor and we are ready to start creating the application. I have connected my Raspberry Pi Pico, and as you see here, my Raspberry Pi Pico is ready to use and it has MicroPython installed. So then we can start creating our application here in the Ton editor. So then I just click on the new here, and then we are ready to start creating the application. Then I just need to import this machine library. So then from machine I need to use this ADC part, because I'm going to read the voltage value from the sensor, which is connected to one of the analog to digital converters pin on the Raspberry Pi Pico. Like this. Then I can just define the pin I'm using. So I'm using pin according to the wiring I showed you earlier. I'm using the first ADC pin, which is 26, and then I just define a variable temp36, and then use the ADC part of this machine library, which just need to define the pin like this. So now we are ready to start reading the temperature value from this sensor. To save some time, I made already a function that is called read temperature, which is basically reading the raw ADC value using this read U16. Then it converts to a voltage value, and then converts to a temperature value in degrees Celsius. I just run it, so I get 1 decimal in the answer. And here I just also print it to the screen, so then you can see it here in the shell when I run the application later. So that's the starting point. Next I start by creating a simple while loop. So then while true, a while loop that goes forever until you, in this case, click the stop button here in the Ton editor. Then I can find the value, degree Celsius, which is basically using this function like this. So basically also since we are using a while loop, we typically need to have a sleep function. So then I also need to import from the time library, import sleep like this, and then I can just specify here sleep and number of seconds, and then I can specify, let's start with just 5 seconds like this. Now we can run it, and as you can see, we are able to read the temperature value and then print it here in the shell every 5 seconds. So the next step now is to implement the writing to this text file feature or functionality as part of this application. Then I start by opening this text file. So then I just specify a file name. It could be anything. It could be, I can call it temp36 data. .txt or something, sorry, like this, and then we need to use this open. So then I will open the file using open, and then I specify the file name, and then if it should be write or read, so then in this case it should be write, like this. So then basically this is all you need in order to open a file, and in this case if the file doesn't exist, it just creates the file the first time it opens. If it tries to open this file, and if it doesn't exist, it will be created. Next, I want to write this temperature value to this file. So let's create some logic for that. Also here we can create a basic function for that. We can call it def write file data or something like this. And then inside here we just need to use file dot write in order to write data to this file. So then we are going to write this degrees Celsius. So then we typically need to have an input argument here. We can just call it temp or whatever, but since we are going to make a generic function, it could be other values as temp as well, it could be pressure, whatever, so I can just call it x like this, and then basically we are going to write x to this file, and you can also add a new line just like this, using this n for creating a new line. And then, as mentioned earlier, we also need to, of course I need to have a write as well. And then, as mentioned earlier, we also need to have this file flush in order to save this data x in this case in each iteration inside the while loop. And then we can use this write file data function here inside the while loop, like this. So then just basically write file data, and then the input to this one should be degrees Celsius, like this. So the next step now is just to save the file. So since we are going to write this temperature data on a file that are stored on the Raspberry Pi Pico itself, we need to save this Python script on the Raspberry Pi Pico itself. So then I can just here under view, you have these files. So here you see here in this files view of the tone editor, here I see files that are stored on my computer, and here you see files that are stored on the Raspberry Pi Pico itself. So then when I click the save button here now, I can choose between saving the file to the computer or on the Raspberry Pi Pico itself. So then I select Raspberry Pi Pico and then specify a useful name. It could be write data example or whatever. Click OK, and it has need to have an extension .py. So yes, and then you see it here, it has been saved on the Raspberry Pi Pico itself. So then let's just run this example where I'm reading values from the temperature sensor and then save it to this text file, and all that is done inside this while loop. So let's run it. There's some error here, so let's fix those. Well, basically I get an error here. That's because this x is a number, but since I'm going to write this value to a text file, it has to be a string. So then here I can just convert it to, just create a new variable called value. You can, and then I just need to convert it to a string. I can do like this, using the string function, and then just x like this. So now this input x here, which is basically the degrees Celsius temperature. It's a number, but here I convert it to a string. So then I just use instead of x, I can just do like this. So then I convert it basically to a string, and then this file.write should work properly. So then let's just run it once more. I just save it and click run. And then 25.3 is the temperature. And then 24.9. So let's just stop it. And then you see this temp36 data.txt has been created here on the Raspberry Pi Pico device. And in my program I was reading 3 temperature values, and then hopefully these 3 values will be stored on this text file. So then I can just double click on it, and as you see, these 3 values are the same as I was reading from the temperature sensor, and these 3 values has now been written to this text file called temp36 data.txt. So basically this application has 2 functions, one for reading the temperature value and one for writing data to this text file, and everything happens inside this while loop. I start by reading the temperature value using this function, and then I write data to the text file using this function, and as a result the data from the temperature sensor has now been written to this text file. So now we have created the basic framework for logging data from a sensor and then write the data to a text file, and then we end up with a file like this. So let's see if you can improve this application step by step. So the next step would be interesting to also save some time on the same file, so we know which value this when this value actually happened in time. So then we can try to improve this application by also include some basic timing in this text file. So then I can just, assuming you want to log data every 5 seconds or 10 seconds or whatever, so then I just use a variable instead of just hard coding 5 like this. So now we can easily change it to 5, 10, 20, 60, whatever. And then we can also we need to then upgrade this write to file data function with some t for time, like this. And then we need to do the same for t. We can just convert it to a string, like this. And then in the right here we need to make now 2 columns, one for time and one for x. So then I just have t plus, then I use this sign, a tabulator. So then now in this file we will have 2 columns, one for t and one for x, which is the temperature value, which is separated by a tabulator, like this. So now we have updated the write file data function. So let's also update the logic here inside the while loop. So then we need to have the time here as well. Then we can also define just k equals to 0 here above the while loop, and then inside the while loop we can just use k equals to k plus 1, just having a 1, just having a number that are increasing inside the while loop. So the first time k will be 0, then next time it will be 1, 2, 3, etc. And then we can have create a time variable here. So then time will be k multiply with ts, like this. So then first time k will be 0, so then TS will be 5, so then 0 multiplied with 5 will be 0. In the next iteration, K will be 1, so 1 multiplied with 5 will be 5 seconds. Next iteration, then K will be 2, so 2 times 5 will be 10 seconds, etc. So then we have created some simple time variable like this, so then we also need to include that one in the right file data. So then just time, comma, degrees Celsius like this. So basically that should be everything. So then I just save it, and then I click run, and let's just log some data. So we have 25.7, 25.4, 26.8, and then finally 25.6. So now we have 4 values. Then I just stop it, and then let's just open this text file like this. So now we have 2 columns. The first column here is 0, 5, 10, 15, which is the time. So first 0 seconds, 5 seconds, 10 seconds, 15 seconds, etc. And then here we have a tabulator sign, and then we have the actual temperature value like this. And for each iteration, we also create a new line character. So then in each iteration, we create a new line, and then we end up with a text file like this, where we have 2 columns, one for time and one for the actual temperature value from the TMP36 temperature sensor. So now we have been able to create a simple data logging application. We are reading values from a temperature sensor and then log the values to a text file using MicroPython, and the file itself are now stored on the Raspberry Pi Pico device. And then here you see the code, and here you see the final results, where you have this temp36 data.txt file that we have created with 2 columns. One is the time itself, and then the second column is the values from the temperature sensor. So let's improve this application even further. So in order to improve the code structure, we will create a separate Python module and a separate Python file with 2 classes. Then we will have a class called sensor that deals with the sensor reading, and then we will have a class called file that deals with the file writing. And then we end up with this code. So here is the new file where we put create 2 classes, one called sensor and one called class, and then we save this in a separate file called we could call it datalogging.py. So this will be a separate Python module, and in the sensor class we create this read from the temperature, which is basically the same as in the previous example. This is the code for retrieving values from the sensor, and then in the file class we have the same, this write data function that are actually writing the data to this text file in 2 columns, time and x, which is the actual value from the sensor. And then you can use this data logging Python module in the main file, which you see here. So then I just use from data logging import sensor, which is here, and file, which is here, and then I just define the sensor as in the previous example, and then I just initialize the file according to this code, and then we have the same while loop where I just use the read temperature in order to get the temperature data, and then just use the write data function in order to write data to this text file in 2 columns, a time column and a value column. So basically this will work in the same manner as in the previous example, but I have just structured the code to make it more reusable. Then in this way I can easily reuse this Python module in other applications as well. We can improve it even more. So the ultimate goal is to run this application without having it connected to your computer. Only the Raspberry Pi Pico is connected to an external power supply, and then we want to have this data logging running by itself. It could run 24/7 without having an external computer attached to it. So in order to do that, this main application, so both the data logging, the Python module, and the main application needs to be saved on the Raspberry Pi Pico itself. But this main application, in order to run it without having a PC attached to it, the file has to be named main.py. So this file has to need to have the file name main.py, and then when we unplug the computer and then put in a power supply, then this application can run 24/7 without having an external computer attached to it. And also, if we don't have an external computer attached to it, then we cannot use this, we will not see the temperature value when we use this print command in Python. So in order to actually see that the application is running, I have added a feature for updating or toggle the built-in LED in each iteration inside the while loop. So this makes it easier to actually see that the program is running. So here you see the final data logging application. So it's the same, data logging.py, which is the Python module with two classes, sensor and the read temperature function, and we have the class file and the write data function. In addition, in the main application, which is now called main.py, which is basically the same, but I have added this LED.toggle, and here I specify that pin 25, which is the built-in LED that is part of the Raspberry Pi Pico hardware, will now toggle, so it in each iteration here inside the while loop it will turn on and off, and this makes it easier to see that the application is actually running when we don't have this external PC attached to it. So now we are back in the Tony editor. Here I have created this data logging.py, which is the Python module with two classes, sensor and file, and each class has one function. In the sensor we have read temperature, and in the file we have this write data. And then we have this main application, which is now called main.py, and both the data logging and the main are now stored on the Raspberry Pi Pico. So here we have the data logging, this one, and then we have main.py, which is here. And then you see the new here is that I'm toggling this LED, so it's easier to see that the program is actually running. So now in the test phase I will use it here in the Tony, and if everything is working I can unplug the cable from my computer and just plug in a power supply, and then the application can run without the computer attached to it. So let's just try it. And now we are able to read the temperature value. So let's just read 3-4 values and then open the file afterwards. So now we have 4 values, and then we have 5 values, and then I will just stop the application, and then I will just double click on this text file, and then you see it has these 5 values. So basically we have now created a data logging application that can actually run without having a PC attached to it. So now we have logged the data from a temperature sensor and then saved the values to a text file. So the next step now is to do some basic data analysis. So basically we will copy the file that we have created on the Raspberry Pi Pico device, and we will copy it to our computer, And then we will create a Python application or Python script that do some basic data analysis. So basically we will create a script in Python that will open this file and read the values from the file and then plot the temperature values inside a chart in Python. And then we'll just use ordinary Python and the matplotlib. So here you see a basic example. So we will import the matplotlib. We will start by opening the file. So open, a name of the file, and then now we need to use the read. And then inside our for loop we will read a line by line of this text file. And then put it into two variables or arrays, one for x, which is the time, and one for y, which is the temperature values. And then when we have put all these values inside these arrays, x and y, inside the for loop, we close the file, and then we are ready to plot the data using the matplotlib. Then we just use plot.plot, and then x and y, which is now two arrays. So basically that's all. So let's go back to our Tony editor and let's see how this is working. So now we are back in Tony. So here we have the data logging Pi, which is the Python library that contains the code for reading temperature data and save to file. And then we have the main application that we know have been running for some time, and then we get a value like this or a result like this, where we have two columns, the time and the temperature values. And then now we are ready to start creating a simple data analysis application as shown earlier. So we just import the matplotlib, we open the file, and inside a for loop we just put each line of this file into two arrays, namely x, which is storing the time values, and then y, that are storing the temperature values. And then we just close it, and then we just plot x and y using the matplot library. So let's just save this now. So now this should be not stored on the on the Raspberry Pi Pico. It needs to be stored on the hard drive. So then I just save it on my computer, and then here I have just a temporary folder. I can call it data analysis example or something .py. And then you see it said here on my hard drive, and now here in the bottom we need to, so now when it says MicroPython here, Raspberry Pi Pico, the code is running on the Raspberry Pi Pico, but now we just need to run it on our local computer. Then we just say local Python 3 like this. So now when I run this code, it will be run on my computer and not on the Raspberry Pi Pico. And then also the next step now, before I do that, I need to go back. I need to copy this data file, this one, to my computer. So then I just right click on it and download to the same folder which you see here. So now a copy of the text file has been so then I just close those so I can open it. A copy of the text file has been stored on my hard drive, and here I have the data analysis file. So then I just go back here, select local Python, and now I can run this script by just clicking the run button. Well, I had a small code error here. Before I plot it, I need since this data here is now text, I need to convert it to a proper data type. So then I convert the timing to an integer, but also I try to convert this to an integer, but this is a floating number. So then I just, instead of int, need to use float like this. So then just run it now, and then you see I end up with a chart like this, where I'm actually plotting and the time versus temperature in degrees Celsius. So basically, this is how we create a simple data logging and data analysis applications for the Raspberry Pi Pico. So that's all. So good luck with the Raspberry Pi Pico and your data logging applications. Thank you and goodbye.